On this part of physics, we are going to talk about voltage and capacitors. What is voltage? What is the potential difference? If I have a wire here or a conductor, and there is a charge here, and this charge, it needs work in order to move it from this point, from point A to point B. So the work needed now to transfer this charge from point A to point B divided by the amount of the charge itself is called what? The voltage or the potential difference. So what is the potential difference? Potential difference equals the work or the energy used to transfer or to move a charge from a point to another point. This amount of work or of energy divided by what? By the charge itself. This is called what? Voltage. And this is now one or the first one or the first formula of what? Of voltage. So it equals W over Q. Okay, second one here now. If I have a electric field or a uniform electric field. What is electric uniform field? It is the field that has all the lines, as you see, parallel to each other, and it's uniform in all what? In general, in all the places of it, it has the same what? Intensity. So this uniform electric field, it is linked to the distance. It's related to the distance between the two plates here, higher potential plate to lower potential plate, and also it's related to what? To the voltage. What is the voltage in this case, in the case of uniform electric fields? In this case, the voltage will equal the electric field strength, which is E, the electric field strength, which is Z, times the distance between the two plates. And this is now the second formula for what? For the voltage. So you have now first formula, and we have here what? Second formula. So that means two formulas to know. Third formula is related to the capacitor, and we can understand here what is the capacitor, and I can say a simulation for that. In the capacitor, the capacity of the capacitor, and we can understand what is it. It equals the Q, which is the charge, over the voltage. And now here, this is now a third formula for voltage, which is potential difference V. And another formula, and we're going to use it in next sessions, but it is the fourth one, where the voltage equals what? I, which is the current times the resistance. So you have here four main formulas that are related to what? To the voltage as seen here, V here. Okay, now we understand this one here. It is related just for electric, for uniform electric field, and this one now is related for the work that needed to move an electric charge from point A to point B, and this one is related to the capacitor and capacity, and this one is related to the current and the resistance. So based on where is the question and what is given in the question, you can choose then to memorize these formulas, and you know what to choose to solve the question. Okay, what is capacitor and what is what? Capacity. A capacitor is two plates, plate here and plate here. And these plates, these two plates, are conductors, are from what? A material that is what? Conductors. And between them is dielectric. Between them here is dielectric material. So that means insulator. Between them is what? Insulator. These two plates and the material between them is now classified as capacitor. What is capacitor now? Is a device that we use it to store energy in it. We store what? Energy. How this energy is stored? Okay, we're gonna see it here. These ones here, I have this one plate, and this is a conductor, and I have a plate here, and this is also conductor. And between them here as a gap, which is dielectric what? Material. So that means insulator is between what? Between them here. In the middle is what? Insulator. Now, as we know for nature now, the elements or the materials that is here on this plate and this plate, number of electrons equals number of what? Of protons. Number of electrons equals number of what? Of protons. So that means these two plates now, they are neutral. So that means they are not positives and they are not what? Negatives. Okay, now what will happen if now these two plates, as you see, are connected into what? Into a battery that is connected to a voltage. This voltage now, if we apply now voltage, the voltage now is 0, as you see. If we increase the voltage, what will happen? What will happen, as you see? While we are increasing the voltage, you see what happens to the charges of what? On the plates. What happens now mainly? What happens now? We will increase the when we increase what? The voltage. When we increase the voltage now, electrons from here, electrons from this place, electrons, they move from this plate through the wire, through the conductor into this one, and they move back to what? To the other plate. So that means this plate now that is positive, that means number of electrons now are reduced on it. So that means the protons are more, so the positive charge is there. And the electrons, when they come here now, so this plate now will have more electrons. So more electrons, that means it is negatively charged. So now, when we increase, as we see, when we increase the voltage now, look here, the charge now, as you see, increased. Here now that means the charge here, the charge what? Becomes more on what? On the two plates. Now, if we take this one now, if we take this battery away now, this battery now, if we take it away, these two plates will remain as they are. That means the charges in them will remain there. So that means these charges now that are on the two plates are stored electricity, and this is what is called what? What is called capacitor. And now if we link these two wires, if we then relink them, to a bulb, into a bulb, we're going to see that then these ones now, these electrons, they're going to move them through this wire into the bulb. Then we're going to see that the bulb is what? Becomes or light up. So that means capacitor is a device that contains two plates and a dielectric material or insulator between them, and these capacitors are used to store energy inside them, which is electrical energy inside them, or electricity inside them. Then this electricity can be used for other things, and it's used in too many electronics devices. It has many uses. Okay, now the capacitance. What's mean? This now we understand what is the capacitor. But now, what is the capacitance? Capacitance is the amount of charges that can be in. Here now, look here now. We understand now the capacitor. It is a device that we store energy in. But how many charges can stored in this capacitor? Any capacitor, all the capacitors will store the same amount of charges. Okay, we go back here as it was here. We go back here as 0, 0, as it was here. Now, we need to understand now these two plates, which is the capacitor, how many charges can store in, and what is the factor, or what are the factors that affect the capacity. That means the capacity, that means the volume of charges that can be charged what? N. Okay, we're going to put this one here now. As you see, this one here will show us what? This one now will show us the capacitance inside these two plates. That means the amount of charges, and amount of charges that can be inside are used with what? With unit called what? Farad. This one is what? Capacitance. Okay, now when does capacitance increases? And when does it increases? It depends mainly on the size and volume and area of what? Of the capacitor itself. And it depends on the material that is used to manufacture the what? The capacitor itself. How? Here now, for example, here, if we increase here, as you see, in this condition now, as you see, what is the capacitance? 0.18 times 10 to the power of negative 12. Okay, what will happen now if I increase the area of the two plates? Look to the capacitance, what will happen? Look, as we increase the area of the two plates, what happens? The capacitor increases. The capacitor here, what? Increases. So that means as the area of the two plates of the capacitor increases, the capacitance, what? Increases. Okay, what about the distance between the two plates? The distance between the two plates. If we increase the distance between these two plates or decrease it, will the capacitance be changed or it will be affected? We're going to see here now. If we increase, as you see, now the separation here, as you see, is 5 millimeter. As you see here, the separation between the two plates is what? Is 5 millimeter. Okay, if we increase now this separation between the two plates, what will happen for the capacitance? That is now 0.52, as you see, times 10 to the power of negative 12 farad. Okay, if we increase it now, if we increase the separation, you keep an eye on the capacitance, what will happen? So as you see, what happens now? Does it decrease or increase? It was 0.52. Now it becomes just 0.26. So that means if we increase the separation between the two plates, if we increase the distance between them, capacitance will decrease. So the capacitance depends on the geometric design of the capacitor, and it increases as the area of the two plates increases, and it decreases as the distance between the two plates, what? Increases. And also it depends on the type of dielectric, what material that is used here. It depends also on the dielectric material that is used here. So I understand now what is capacitance, I understand what is capacitors, and what is the capacitance, or what does the capacitance depend on. And just we say what's the formula that links that. We said the capacitance of any capacitor, it equals the charges that are stored in this capacitance over what? Over the voltage. This one is also a formula that we said earlier. Okay, now so that means capacitance, it depends on the geometric design of the capacitor. And that's related to the capacity that it can be on. Okay, if I have now just one example to this idea. By the way, the capacitor in electric circles, it's simple. That means they are what? Equal. Like it is like, it shows that this is a capacitor and it contains two parallel and equal plates. Okay, if I have now an example, this example here now, if I have two balls, this is now one big ball and this is what? A smaller ball. If these two balls now have the same amount of charges, that means same Q here, same Q here, same what? Same charge, the same charge. Okay, so Q1 equals what? Q2. Now, and these two balls are conductors. If we bring these two balls together, to connect them together, that means to keep them in contact, what will happen for the charges? So that means here they have the same number of charges here, same number of what? Of charges here, same number of charges in the left, same number of charges in the right. Now what will happen when we keep them in contact? Will the charge move from the big circle to the small, from the big sphere to the smaller sphere, or from the smaller to the bigger, okay, ball or sphere, what you call it? So when we keep them in contact now, here now, as you see, we have the same charge, but the capacity of this ball is smaller. The capacity is what? Is smaller. And since the capacity is smaller for this ball as geometry, since the capacity is smaller, so the voltage is high. So the voltage is what? High. So capacitance, as we know, it equals Q over what? Over V. So that means when the capacitance is small here for this ball, that means the voltage is what? Is high. But here now, as you see, C equals Q over V. When the capacity here for the big ball is high, that means the voltage is what? Is small. So what will happen in this case? The charges will move from the small ball into what? Into the big ball. So that means they'll go from the higher level. And as we know in general, The charges, they go from higher level areas into lower potential areas. That means from higher potential to lower potential. That means from higher voltage to lower voltage. So the charges will come from a smaller ball into the bigger ball until until the voltage in both of them becomes equal, until the voltage of both of them will equal each other. So you understand now on this part what is the formulas that as related to voltage, and we understand the capacitor and capacitance and how they are related to each other and what they depend on. Questions based on this video, you find them in the quiz, you can solve them.